So before, with an inelastic collision, you'd have two objects. Each of them had some kind of velocity. And these were known values, right? They would give you the mass of each object, they'd give you the velocity of each object. They crash into each other, and afterward...
Because one was going faster.
Yeah. Or maybe they're going opposite directions, it doesn't really matter. But afterward, they stick together. They keep moving together.
Which is inelastic.
Yeah, so this is called a perfectly inelastic collision. The reason you know it's inelastic is because they don't bounce. Okay? So they don't bounce at all, they hit each other and they stick. So this would be like, I don't know, they use the example in the book a lot of like two balls of clay that hit each other and they stick together and move off together. Or for maybe if a car crash and a car crash, if they crash together and then stick, they slide together. And when this kind of thing happens, momentum is conserved. So the initial momentum is this momentum plus this momentum, right?
Yeah.
Okay. Can we find P1?
If we know P2, yeah.
Well, so they'd give us the mass and the velocity of each of these, right?
Yeah.
So we'd know M1, V1. P2, we know M2, V2. Okay? So what's our final momentum then?
Either we can go ahead and solve for each P1 and P2, or we can add up the M2 times V2 plus the M1 plus V1.
Right. So say we were looking for this velocity of both of them. Is the velocity, so this would still be P1 plus P2, right?
Yeah.
But now the momentum of P1 is M1 V final 1 plus M2 V final 2. What do we know about these two velocities? If they're stuck together.
They're going to be the same.
Right, so we can actually treat this as one mass. We could say this is M1 plus M2 times the velocity final. And this is our only unknown, right? So if we wanted to solve for velocity final, we could say M1 V1 plus M2 V2 equals M1 plus M2 times velocity final. Okay? The only unknown we have is velocity final. This one. So perfectly inelastic collisions we can solve just with momentum. Does that make sense? So if it says two objects collide, it's perfectly inelastic. That means they stick together and they move away together. You can solve it just with momentum. Momentum will be conserved and you'll be able to solve it. Okay? Now, what happens if instead you have a perfectly elastic collision? What do you think that means?
The second one is always going to move faster than the first one after they come in contact.
Well, not necessarily. Let's actually erase this for now, just for the sake
Or
of
equal to or greater.
Well, what'll happen after they hit each other? They might separate. So you can have mass 1 going this way, mass 2 going this way. Will the speeds be the same?
Not necessarily.
No. They usually won't. Sometimes they might be, but typically no. Okay. So we still have for momentum, we have M1, V1, M2, V2. So we could say our initial momentum is equal to M1, V1 plus M2, V2. Okay? And our final momentum, we could say it was equal to M1, V1 final plus M2, V2 final. And then we can set them equal to each other, right? So this is trying to solve it just like we did with a perfectly inelastic collision. But now what's the problem? Do we know this velocity?
No, we don't know either of them.
No, we don't know either of them, and they're not the same. So now we have only one equation with two unknowns. So with a perfectly inelastic collision, you can solve it just with momentum. But with a perfectly elastic collision, you have to use momentum and energy to solve it. The book talks about it, it teaches you what happens, but we're gonna kind of skip through it because it's a lot of just work, really. Okay. So if you go through here on chapter 10.6 under elastic collisions, it has this equation for momentum conservation, which is what we did. Then they do the energy conservation equations too. And then they solve them.
Oh yeah, we went over the energy conservation one, I remember.
Right. So we've done momentum conservation and energy conservation. But now, in order to solve this kind of problem, you need both. And the equations you end up with are velocity final of object 1 is equal to m1 minus m2 all over m1 plus m2 times the velocity initial of 1. Okay? The velocity final of ball 2 equals 2m1 all over m1 plus m2 is velocity initial 1. Okay?